UTME Physics practice problems. I'm currently on question number 3. So for question number 3, we have a ball which is thrown with a velocity of 20 meters per second at an angle of 30 degrees above the horizontal. When the ball reaches the highest point, which of the following is going to be true? So this is a typical projectile motion problem. And so if I draw the projectile part, let's say in this manner, now we are interested in what is happening at this highest point here. One of the things you should know about a projectile motion is that there are two components of velocity. First, we have the horizontal component of velocity, and we have the vertical component of velocity. The thing about the horizontal component of the velocity is that it is always constant. It is not changing. That is why in the horizontal, there is no what? There is no acceleration in the horizontal. But for the vertical component, when it's going up, it's actually decreasing its velocity as it's going up. And it gets to a particular point here such that the vertical velocity is now going to be equal to 0. Don't forget, it was decreasing as it was going up. But when it starts coming down again, this 0 velocity will start being gained back. So you start gaining the velocity back again. However, don't forget, in that same situation, the horizontal component of the velocity still remains the same, its original value. So let's now answer some of these questions. So option A says that it has 0 velocity. At maximum height, it does not have 0 velocity. If it had said that it has 0 vertical velocity, that would have been correct. But 0 velocity is not true because the velocity has two components, the horizontal and the vertical. And for this to be 0, that implies that both components has to be 0. So A is not going to be true. B says it has 0 acceleration. That is not true as well. Of course, from the initial stage, horizontal, there is no acceleration. But for the vertical, as long as there is change in velocity, then there will be acceleration. So the velocity continuously change in the vertical component. And this acceleration is actually g, which is acceleration due to gravity. So saying it has 0 acceleration is not going to be true. It has minimum potential energy. For potential energy, in this case, we are dealing with gravitational potential energy, which is given as mgh, mass times gravity times height. Since it has reached its maximum height here, that implies that at this point it has its maximum potential energy. Potential energy is not minimum here. And the last option says that it has minimum kinetic energy. That's going to be our guy, and let's look at it. You see, for every point here, the magnitude of the speed of this guy, which we will use to actually find the kinetic energy, the magnitude is always square root of v vertical squared plus v horizontal squared. That's the magnitude of the speed. So this is the speed we use in our half mv squared to find kinetic energy. When you look at the value of this guy, for every point here, there is always the horizontal and the vertical velocity, every point that you get to. But you see, when you get to this point now, the vertical component becomes 0, and then you only have the horizontal component. And that place you have minimum speed for this body. Hence, the kinetic energy is minimum at the maximum height. And that answers the problem. Let's go to question number 4. Question number 4 says that for an object moving in a uniform circular motion, the direction of the linear acceleration vector is. Now, if you say linear acceleration vector, it's actually a very, very technical question. In a circular motion, we consider 3 types of acceleration. There is the acceleration that is moving inward from the part of the cycle towards the center. This is called the centripetal acceleration. This is also called the radial acceleration. But there's also what we call the tangential acceleration. The tangential acceleration, which is a tangential. Now, both of these guys, they are actually linear acceleration vector. But there's one more guy that I need to put into consideration here, which is the angular acceleration. And when do we have angular acceleration? If this body is moving such that it is increasing its angular speed over time, then you have angular acceleration. But in this case, this is a uniform circular motion, meaning that the angular speed, not only the velocity, the angular speed is also increasing uniformly. So meaning that this guy is equal to 0. But here's the thing, this tangential acceleration depends on this angular guy because tangential acceleration equals alpha multiplied by r. So if this alpha is 0, then that means that the tangential acceleration is also equal to what? 0 as well. So in this case, we can say that the tangential acceleration does not exist in this situation. Now, we are left with what? Centripetal acceleration. So in the uniform circular motion, the only linear acceleration vector that we have there is this centripetal acceleration. So A says tangent to the path of the motion. That is not going to be true. I just said that we don't have this in this kind of situation. B says towards the center of the circle. Yes, that is correct. This says radially outward. This one does not even make sense. It says it's equal to 0. No, it's not equal to 0 because the linear acceleration vector is not equal to 0 because it is made up of both this and this guy. And since one of them is directed toward the center, that implies that that will be the correct answer. So B is the correct answer in this situation. Let's see, we can quickly solve question number 5. Question number 5 says that a uniform meter rule of weight 1 Newton pivoted at the 40 centimeter mark. So let's see. So you have a uniform meter rule. It has, since it is uniform, that means that it's going to have its weight acting at its center. They say it's pivoted at 40 centimeter mark. So let's say this is 40 centimeter mark. You place the pivot here. So because it is uniform, the midpoint of the meter rule will be 50 centimeter. Total length is 100 centimeters. So that means that the weight is acting here, which is 1 newtons. Then a weight of 2 newton is hung at the 15 centimeter mark. So a weight of 2 newton is hung here. Where must a weight of 5 newton be placed to balance the rule? Now, in this case, there are so many ways you can actually do it. You can decide to place your 5 newton anywhere on the meter rule and just make some assumption. Then you will see, you will still get the same result. So let's say I'm putting the 5 newton here, and let me make this place x. So we're going to take the moment about the pivot. So for instance, we can take the moment of this. This is going to be the what? Anti-clockwise. And these two are going to move clockwise actually. So if you do this, between 15 and 40, what's the difference? I think the difference should be 25. So that means that the moment here will be 2 times 25. That will be equal to, between 40 and 10, that's 50, that's 10. So 1 times 10 is what? Is 10 plus, this is going to be 5 multiplied by what? X minus 40, because I don't know. So the distance between 40 and x will be x minus 40. So 2 times 25 is 50. Don't bother about converting from centimeters to meter because you are comparing them from left and right, so it will definitely cancel out. So you have this is equal to 10 plus, if you open the bracket here, you have 5x minus 5 times 40 is 200. So from this place, you can take the 200 to this side. So that will be 50 plus 200 minus 10 equals what? 5x. So and finally you have 250 minus 10, that will be 240. 5x. So you divide both sides by what? By 5 in this place. So 5 in this whole place, 5 in 24, that is 4. Then you have 4 left. 5 in 40, that's 8. So that's 48 centimeters mark. So meaning that, so you can see that even though I placed it beyond 50 centimeters mark, when I solved for x, it was still able to give me the right answer. And also the answer will be 48 centimeter mark. And that's the answer for this question. Don't forget to like, comment, and follow to see the solution for the remaining 70. I'll see you in the next one.